It looks like we're back in 1.16 and in the same like boat ice track thing. Oh, we have the materials to make a flying machine. We can use that to teach you. We can use that for speed and velocity graphs as well, because flying machines, if once I build this, have constant speed and or velocity, and they don't have constant displacement since it's always moving, but it has constant speed and velocity and zero acceleration because it has constant speed and or velocity. Uh, ah, and then and then the and then with these we have a flying machine that's moving at constant speed and velocity, since it's returning back to where it started, because we've set it as just moving infinitely in the south direction. And we can calculate the speed and velocity of that with the graph shown on screen right now. So let me explain these graphs now. For the displacement versus time graph, since the flying machine was moving continuously, its displacement would be continuous as well. So that's why it's a diagonal line. And at 10 seconds, it moved 20 blocks, and at 20 seconds, it moved 40 blocks, and so on, because it moved around 100 blocks in 50 seconds. So that's what this would be. And then for a displacement versus time graph, the slope of that is velocity. So for this displacement versus time graph, it moves 20 rise over run. 20 blocks over 10 seconds, which is our velocity then. 20 over 10. 20 blocks over 10 seconds, which is 2 blocks per second, which then leads us to our second graph. So initially it was at 0 velocity or speed. And then in that brief second where it started, starting off the machine, it started moving a little bit faster, so it accelerated. So its velocity, and so that's why the velocity has a line from 0 to 2, since the slope of a velocity time graph is acceleration. So it accelerated to 2 blocks in, I think, 1 second, so which then gives our acceleration of 2, since 2 over 1 is just 2. So we have 2 blocks per second over 1 second, which is 2 blocks per second squared over 2 blocks per second, and we just have a constant velocity because the flying machine wasn't accelerating or decelerating after that point. And then for the acceleration time graph, we have 0, and then we go to 2 seconds instantly, and then our acceleration redrops back down to 0. That's why there's no line at 0, since it can't be seen, since there's no acceleration, and since it's not accelerating because the flying machine isn't speeding up or slowing down, so that's why it has 0 acceleration. So it has continuous displacement or distance, constant velocity or speed, and then no acceleration after the first second. And then in Minecraft, we also run at a constant speed or velocity, but when we sprint jump, then our speed and velocity increases, because we move faster that way. So walking would have let's stop sprinting. Walking would have its own speed and velocity, and then sprinting would have its speed and velocity, and then sprint jumping would have its own speed and velocity, and then sprint jumping with speed 2 would give us a little bit faster for speed or velocity, and then there's also just normal sprinting with speed 2, which is the fastest out of all of those. And since we went all the way there and came back, our velocity should end up back at 0, or maybe a little behind 0 because I might have gone further behind it. But our speed would gradually increase as we do that, and because our speed or velocity is increasing, we have acceleration, and that will be shown with a graph on the screen right now. Okay, so for the graphs of the running example, so the distance versus time graph. So the distance versus time graph, it's kind of a curvature, but we can't really see it because the values are very similar, so it doesn't look like, so since the velocity values are very similar, you really can't tell much of a curve between it. But there's a curve because you start slowly by walking, then by sprinting, then sprint jumping, and then sprint jumping with speed 2, and then just speed 2 itself. And then we eventually return back to 0, or maybe a little bit after that, but I'm just going to count till 0. Then, and as stated earlier, the the slope of this is velocity. Then for velocity versus time, there's a slight slope, then flatten out, and then slight slope and flatten out, and slight slope and flatten out. So there's a slight slope because you don't instantly start moving at 4.317 blocks or meters per second in Minecraft. You slowly you don't instantly have that speed. You just slowly get to it, which I'm just saying is 0.2 seconds for all these things. So you slowly increase to walking speed, then sprinting speed, then sprint jumping speed, then sprint jumping with speed 2. Then when you turn around, then you have negative velocity, and we have negative 7.857 meters or blocks per second with when we turn around, and that's why we have a large dip to negative 7.857 blocks per or meters per second. And then we eventually return back to 0 because at the end we stop. Then for acceleration, there's a slight bump. There's a great bump at the start because when we start from moving from 0 to 4.317 blocks or meters per second, we had a great increase. Then, as our velocity was constant, our acceleration was back to 0. Then we have a slight bump of acceleration, or slight increase of acceleration, because we slightly increased our speed from 4.317 meters of walking speed to 5.612 meters per second of sprinting speed. So that's why there's a small bump, and then there's a bigger bump because of moving from sprinting to sprint jumping. And there's a slight bump when we go from sprint jumping with speed 2 because our velocity doesn't really increase by that much. And then later we have a very large dip in acceleration. We have negative acceleration because then we move from 7.3 meters per second to negative 7.857 meters or blocks per second. And then our acceleration was back to 0 because we were moving at constant velocity and then stopped. So that's why we have 0. That's why our acceleration is like this. Before I end this, I would like to say that the slope of a position versus time or displacement versus time graph or distance versus time graph would be velocity. And for velocity versus time graphs, the area under the graph tells us displacement, because if you divide what's the rise, it's blocks per second over seconds, we would get just blocks, which would then give us, which is just a form of, which is then just displacement. And then with that, the slope of velocity versus time graph would be acceleration. And then for acceleration versus time graph, our slope doesn't tell us anything yet. And then, And then our area under that gives us not just velocity, our change in velocity, because under the acceleration, it's not just velocity, it's change in velocity. Since when we are calculating acceleration, we're calculating a slope, which is v final minus v initial, which then gives us the slope which gives us a slope in velocity versus time graph, which is acceleration. So our velocity so then that's why we have a change in velocity and then just velocity, because we had to calculate the difference between the two velocities to get the acceleration.